Good morning, students. I hope you have completed the two sums that I gave as homework for the weekend. Um, that was related to the test of for a specified mean and test for equality of two means we did. Third type we will do today. And if you have any doubt in the previous two types, you can unmute and ask now. When I'm teaching, you can just stop me and unmute and ask. Okay, since we are running out of time, only 10 minutes are already gone almost. So I will start now. And if you have any doubt, anything to ask for from your homeworks, you can ask by stopping me. Okay, I will explain. Third type of test or small sample test, that is t-test, includes the test for equality of two means paired t-test. These are called paired t-test. Okay, so in today's heading you can write paired t-test. All right. So what happens here is in the previous type of problem, no, where we are testing the equality of two means, we were taking two samples of different sizes, right? In there the samples were of different sizes, but here in this type of test you will see that the sample will be same, that the sample will be same. What does it mean? Suppose a sample of 10 people has been selected, and one application will be given. Say for example, um, the fluctuation of this temperature of these 10 people before being vaccinated with Covishield, and the fluctuation of temperature of these 10 people. Say you are taking 6 months data and then you are doing the test. Okay, so the fluctuation of temperature in this 10 people before being vaccinated, and the fluctuation of temperature of these 10 people after being vaccinated for the past 6 months. So this kind of test, okay, same people, same set of sample will be there, but they will be tested for some reason. They will be applied with some medicine, and say for example you can take it with animals also, or plants. Pesticides is being applied, and before the application, after the application, what are the results you want to test. So this kind of test you will see over here. Okay, so just note down the formula quickly. This p statistic will be of d bar. In the numerator it will be d bar divided by s, the, again divided by root over of n minus 1. Okay, so what does this d bar will mean? Quickly write down this formula in your copy. Okay, and if I'm going too fast, I have to complete this one. That's I've started fast. So if you're missing the flow of my teaching, what you can do is, when I upload the recording today only, I'll upload. Okay, what you do is you pause it and then write, pause it and then write, like that you can do. So test statistic, what will be the value of it? It will be t equals to d bar divided by s divided by n minus 1. Okay, in the denominator there are two parts, one is s and one is n minus 1. So what does this d bar means? D bar means the mean of the difference. Okay, so what will you do is, okay, I will show you one problem, then you will be clear about this d thing. Okay, what is this d is? This is the difference in the values of two samples, of the two sets of two values of the same set of sample. Okay, some values will be given before and after. Okay, so the difference between before and after is the meaning of d, and when you take mean of it, that is the average of this d value, you get d bar. Then what does s denote? S denotes standard deviation of the difference. So what does it mean? The difference that you will take, that is xi minus yi, that means the value before the application, after the application, the difference of that value, that standard deviation of that difference is denoted by s, and n is the sample size. Okay, so the formula of s square is summation di minus d bar. You need to write this formula also. D bar equals to summation di by n, and s square equals to summation di minus d bar whole square divided by n. That is summation di square by n minus summation di by n whole square. This is a formula for calculating variance, and if you take root over of this formula, you get standard deviation. Okay, In order to get S, you need to take root over of this formula. And by substituting the values for these notations, you will get the value in numerical terms. So what you do is, this is a formula of variance, that is S square. If you take root over of this formula, you get the value of the standard deviation. Any doubt, you please unmute and ask. Okay, so these two formula you have to keep in mind, and rest of the things, that is acceptance and rejection criteria, remains the same. And in t-test, you have to note the degrees of freedom. What will be the degrees of freedom? If you refer to my recordings later on, then listen to it again and again. Okay, in one sample test, that is test for a specified mean, the degrees of freedom were n minus 1. And in the test for equality of two means, by using t-test, the degrees of freedom was n1 plus n2 minus 2. And here in the third type of test, again the degrees of freedom will always be n minus 1. N means the sample size, deduct 1, then you can see the table. By seeing the table, comparing with the tabulated value, you can take the decision of accepting or rejecting the null hypothesis. So here, see this problem, we will solve this problem, then things will be clearer. So what does it say? An IO test was administered to 5 persons before and after they were trained. Okay. So, sorry, IQ. IQ test was done, okay, to 5 persons. So 5 is your sample size. For to 5 person, the one training was provided, and IQ test was done before the training and after the training. Then what are the results? For person 1, the IQ test result before training was 110, and after training it was 120. Like that, data related to 5 persons are given to you. Write the problem later on, write the question later on, leave some space and you can write it later on. For now, you solve the problem first. Okay, then what we need to test? We need to test whether there is any change in IQ after the training program. Given T 0.01 for 4, that is 4 in bracket. See, given the bracket thing in the question, it is said given T 0.014 equals to 4.6, right? What does it mean? 4 in the bracket, small bracket in the subscript, can you see? That 4 means the degrees of freedom, okay? And T at 0.01 means you are getting this tabulated value for T at 1% level of significance, okay? So no problem here, data is given to you, you just have to compare. Okay, so how will you proceed? This is a problem of pair t-test, we all know it. So let us just write the null hypothesis first. How will you write? Null hypothesis will be mean of the data before training is equals to the mean of the data after training. Okay, let us notify this IQ before training by X and the IQ after training by Y. So how will you write the null hypothesis? You will write null hypothesis H naught in bracket mu x equals to mu y. That is, you can write the line beforehand and after that you write the null hypothesis. That is also okay. And before you write null hypothesis H naught mu x equals to mu y, after that you write the line. That is also okay. So what does this mean? H naught mu x equals to mu y. It means that there is no change in the mean scores before and after the training. Okay, so what you are assuming? You are assuming that the training was ineffective, right? The training was ineffective because the mean score before the training and after the training, you are assuming them to be equal, right? So you write null hypothesis H naught mu x equals to mu y. There is no, that is, there is no change in the mean scores before and after the training. All right, just write down quickly, or you can skip writing now. Just listen to me, understand the problem, listen to the recording, pause it, write, pause it, write. Like that also you can move ahead. Okay, I'm going a little bit fast today. I want to finish it fast, that's why. So if null hypothesis is H naught mu x equals to mu y, then H1, that is alternative hypothesis, will be mu x not equals to mu y. Okay. Then for the calculation part, you need to make this table. Make this table quickly. Give the heading calculations for paired T. Heading will be calculations for paired T. Calculations for paired T. X values, bring it from the question. These are given. X values are 110, 120, 123, 132 and 125. And Y values are 120, 118, 125, 136 and 121. So write down the values from the question directly. Okay. For X, they will be 110, 120, 123, 132 and 125. And Y values will be 120, 118, 125, 136, 121. Thus D. These two calculations are important. Okay. One is, always remember, in paired t-test, in the table you have to do these two calculations. One is D and one will be D square. Okay. D is required for mean calculation and D square will be required, as well as D will be required for calculating your standard deviation. So always remember, in paired t-test table you have to do these two calculations. One is D and another one is D square. Okay. So what is D? D is always X minus Y. That is before training value minus the after training value. Here we are using the term training. It can be any type of test. So before the test minus after the test is the meaning of D, small d. Okay. So how will you do? You will just deduct the second value from the first value. That is 110 minus 120. Then 120 minus 118. Next 123 minus 125. Next 132 minus 136 and 125 minus 121. Like that you will get the values. Then in the next row you will do D square. You will just make square of the values of D. Minus 10 square means 100. 2 square means 4. Minus 2 square means 4. Minus 4 square means 16. 4 square means 16. Then you will get the total of this D and D square both. Get the total of D and D square both. Okay. Just add it. Minus 10 plus 2. That means minus 8. Minus 8 minus 2. That means minus 10. Minus 10 minus 4. That means minus 14 plus 4. That is minus 10. Then 100 plus 4 plus 4. That is 116 plus 32. That is how much total? Just find out total of, oh sorry, 8, no, 108 and 32. That is 140, right? So thus we need to calculate D bar, right? Because for using the formula we will need this value. So calculate D bar. D bar will be summation of D divided by N. What is summation of D? It is minus 10. So minus 10 by 5, that is N. You will get minus 2. Next is S square. For calculating S square, what we need? We need summation D square by N minus summation D by N whole square. This is the formula that I hope you have written during the beginning of the class. So you need to use that formula. Formula is S square equals to D square by N minus, in bracket, summation D by N whole square. Okay. That is how you will get the value. 140 by 5 will be 28 and minus 10 by 5 whole square. That means 100 by 5. That is, 100 by 25. That is 4. Right? 4 you will get. So 28 minus 4 you will get 24. If you have any doubt, please stop me and unmute and ask. Okay. Thus we will use the value or the formula of P statistic and we'll find out the value of of it. So T statistic value formula is, in the numerator it was D bar, and denominator it was S divided by n minus 1. So now you will substitute the value of D bar, that is minus 2, divided by, you know that S square is 24. So what will be S? It will be root over of S square, that is 24 root over of 24, divided by, under a big root over, it will be 5 minus 1, that is 4. So using your smartphone, please do the calculation. Okay, root over of 24 by 4 means root over 6. Then find out the value of root over 6. No need to do the calculation in this way. You can use your smartphone and calculate. Okay, I hope you will get minus 0.82. So if you are getting minus 0.82, then you have to remove the minus sign firstly, because this is a two-tailed test. I hope you remember, for two-tailed test we take mod of the test statistic. So T mod we will take, and thus we can ignore the negative sign. So critical region is given, no? Critical region is given that if the calculated value of T is more than 4.6, then we will reject the null hypothesis. So is it more than 4.6? Please tell me, one of you, is it more than 4.6? No, it is not more than 4.6. It is less than 4.6. So it doesn't fall in the critical region. That is, H naught cannot be rejected. That means if H naught cannot be rejected, you will conclude that there is no significant change in the mean IQ after the training program. That means the training program was not effective. Okay, this way you will write the conclusion. I hope it is clear to all of you. I hope it is clear. If you have any doubt, please ask. Please ask if you have any doubt. Okay, so I take that you don't have any doubt. So let us move ahead. Till we have time, so we will discuss this problem as well. Here the sample size is given as 12 patients. Okay, a certain stimulus administered to each of 12 patients resulted in the following changes in blood pressure. So here changes are given. What does it mean? This means that D value is given. Okay, remember, take this very carefully. Okay, see this very carefully. For pair T test, when changes are given, okay, for any test, say T test, if changes are given, then that means it is a pair T test and the D values are given. I'll give you some set of problems to practice, then you can prepare yourself that what kind of questions it can include. So how to identify that whether it is a pair T test? First of all, you need to see the number of sample size. It is 12, that is less than 30. So obviously it is a T test, not a Z test. Okay, it is a T test. Then you need to check whether the values of mean and standard deviations are given in the problem. If it is given, then it will be either of a testing for self-specified mean, or it will be testing for equality of two means. If means and standard deviation are not given, then you need to check whether before some test and after some test values are given. That means same set of sample size, two different values will be given. If this is given, then you have to understand that this is of a paired t-test problem. Okay, so here the difference values are given to you, that is D values are given. So our task becomes easy here. Then it says, can it be concluded that the stimulus will in general be accompanied by an increase in blood pressure? So here this is a problem of one tail test, because the term increase is mentioned. Okay, in the previous sum there was no question of paired one tail test, that is increase or decrease assumption, because it was simply given whether you need to check whether the training was effective or not. But here you see, you have to test whether there is an increase in blood pressure or not. Okay, so this is a one tail test. How will you say? So, say for example, you will write the assumption first. Okay, here the changes d equals to x and y, x minus y in blood pressure is given. This way you will write first in the solution. Here the changes, that is d equals to x minus y in blood pressure, are given. That is, x is the final blood pressure after administering the stimulus and y is the initial blood pressure. So x is the final blood pressure, for example, and after administering the stimulus, that means after the test. Okay, and y is the initial blood pressure, that is before the test. This way you will assume it. Okay, then we are required to test whether the mean blood pressure has increased, that is mu x is greater than mu y. So mu x, you are assuming it to be the blood pressure after the stimulus. No, so it has to be more. Only then your test will be satisfied. You have to test whether there was an increase in blood pressure. So if mu x is the assumption that this is the blood pressure after the stimulus, then it has to be more. So alternative hypothesis will be x mu x greater than mu y. Okay, assume the things properly. Okay, you have to write mu x minus mu y and mu x greater than mu y. H naught will be mu x equals to mu y. As you know that null hypothesis should be in the terms of equals to written, so you have to always assume that the mu x is equals to mu y, like that. Okay, because the null hypothesis has to be written in equals to form. And here, since this is a one tail test, that's why the mu x has to be assumed to be more than mu y. That is your alternative hypothesis. So using the formula, you will now solve. N will be 12, summation di you will take by adding all these values given in your question. Then you will get summation di square. You will also take di square. Okay, d square you will take, that is 5 square, 2 square, 8 square, like that you will do and calculate the total. Then you will calculate d bar, that is summation di by n. So you will get some value. Then you will put the formula of s square, that is summation di square by n minus di by n whole square. Then you will get some value. After that, you will substitute this value in the t statistic formula and you will see that you are getting 2.89. Okay, 2.89. Now, you need to see the degrees of freedom. What will be the degrees of freedom? For checking the table, you need the degrees of freedom. And what will be the degrees of freedom? Remember, it will be n minus 1. That is, n is 12 minus 1. That is 11. So, degrees of freedom will be n minus 1. And then you need to refer to the table that I shared you in the WhatsApp group. Okay. So for one tail test, you remember there were two sections. No, one is one tailed and one is two tailed. So here you need to check for one tail test at 5% level of significance. For 11 degrees of freedom, you will check the tabulated value for one tail test. Okay. All right. So is it given in your question, the tabulated value? Yes, it is given. At 0 p at 5% level of significance for 11 degrees of freedom, it is 2.2. And how much you are getting? 2.89. See, in this problem, it is mentioned that the value is not correct. But if it is given to you in the examination, no, you will take this value only. Okay, you will see this value only. Okay, no need to consult the table because this is given to you, so you will compare with this value only. All right. So what will you see? Whether this calculated t, that is 2.89, is greater or less than 2.2. As you can see, it is more than 2.2. So it indicates that it falls in the critical region. That is, you need to reject the null hypothesis. Okay. We reject the null hypothesis and you will conclude that the stimulus in general will be accompanied by an increase in blood pressure. That means, what does it mean? You are, since you are rejecting the null hypothesis, so you are accepting the alternative hypothesis. That means you are saying that the blood pressure after the dose of the stimulus was more than the blood pressure before the stimulus. So mu x greater than mu y, you are stating. That's why you need to write this. Okay, you will write that this value of the calculated P is falling in the critical region. That is why we reject the null hypothesis and conclude that the stimulus will be accompanied by an increase in blood pressure. This way you will conclude. Okay. So with this we come to the end of our T test, small sample T test. And if you have any doubt, please tell me. Tell me now. Since we don't have much time in hand, I will clear all your doubts tomorrow. And tomorrow also you can say where are you facing problem. Okay, where are you facing problem in doing this T test. And today I will share a set of exercise problems which you can practice. And while practicing, in case you are facing any difficulty, you can please contact me. Okay. So any doubt you can tell me till the time I'm taking your attendance. Okay. I've given you attendance. You may leave the meet now. See you tomorrow. We'll start another type of test tomorrow. You can leave the meet.